Hello and welcome back. In this video we continue our discussion on Newton's first law of motion. Consider the example discussed in the previous video. Imagine that an apple is at rest on a cart moving at a constant velocity. In real life this will only possible when the cart is pulled with a constant force which is balanced by drag and frictional forces at this velocity. The weight of the apple is balanced by the normal reaction from the surface. The apple is at rest with respect to O dash and it is moving at a constant velocity with respect to O. O and O dash are inertial frames of reference. The cart and the apple will remain in their state of rest or uniform motion along a straight line unless acted upon by a net force. Now imagine that the cart is moving with a constant velocity, applies brakes and decelerate. Braking increases frictional force acting on the cart in the negative I direction, resulting in a net unbalanced force acting on the cart in the opposite direction of motion, which is responsible for the deceleration of the cart. Remember, O dash attached to the cart is no longer an inertial frame of reference. But the apple will tend to stay in its state of uniform motion along a straight line with respect to O, which is still an inertial frame of reference. Due to this, apple appears to fly away from the table in a straight line until it is acted by gravity to change its path. Finally, imagine another thought experiment. For the previous case, when the cart is applied brakes, the motion of the apple is prevented by a wall. Now we can conclude that a reactive force from the wall rigidly connected to the cart is opposing the inertial forces experienced by the apple in the non-inertial frame of reference O dash. The magnitude of this inertial force will be mass of the apples times the acceleration of the cart. Finally, here you have a number of questions to answer. When a car comes to a sudden stop, the passenger jerks forward. What is the reason for that? An airplane flying at 30,000 feet with a constant velocity, what is the net force acting on it? An ice skater who stops exerting braking force will slowly come to a stop. Why? A car is moving with a constant velocity. Its engine still works and produces power. What is the net force acting on the car? Let us conclude with a recap of the first law of Newton. In an inertial frame of reference, every body continues in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. Thank you very much for listening.